Welcome to 6.1 Inverse Circular Functions. We are going to start by reviewing inverse functions in general. So the first requirement for a function to have an inverse is it must be a one-to-one function. So let's review what does that mean. First of all, it needs to be a function. So therefore, and a function says that each x value will have exactly one y value. So examples of functions are something like y equals x squared or y equals sine x, because each x value has exactly one y value. One thing we can do to test to see if something is a function is make sure that it passes the vertical line test. So the vertical line test states that each vertical line passes through the function exactly one time. So notice that each vertical line will pass through the function exactly one time. But these two functions are not one-to-one. So now let's review what it means to be one-to-one. In order to be one-to-one, it has to not only be a function, so it will pass the vertical line test, but it will also have the additional requirement that each y value will have exactly one x value. So an example might be y equals x cubed, because every x value has exactly one y value. That's the horizontal. One example is y equals x cubed, because each x value has exactly one y value. That says that it passes the vertical line test. But in addition, every y value has exactly one x value. So this is the horizontal line test, where every horizontal line crosses our graph exactly once. So graphically, in order to be a one-to-one function, it has to pass the vertical line test and the horizontal line test. Now, if a function is one-to-one, it will have an inverse. The domain of the inverse function So if we call our original function f of x, then the inverse of f of x is written as f with this -1 of x, but this is called f inverse of x, or f and f inverse. So the domain, one property of inverses is that the domain of F is the range of F inverse, and the domain of F inverse is the range of F. So basically, the domain and range of F and F inverse are swapped. Lastly, the graph of F inverse is a reflection. Lastly, the graph of F inverse is a reflection of F over y equals x. So if we look at, for example, f of x equals, if we look at f of x equals x cubed, its inverse is f inverse of x equals cube root of x. So if we look at f of x equals x cubed, the red function here, and then we look at its inverse, which f inverse of x is the cube root of x. You could see that they look similar, but they are oriented differently. The way they are related is that they are reflections of one another over the line y equals x. So if you take f and reflect it over the line y equals x, you'll get f inverse. Similarly, if you take f inverse and reflect it over the line y equals x, you will get the original function f. So now let's explore the inverse of sine. So let's look at the graph of y equals sine of x. As we can see, y equals sine of x is a function because it passes the vertical line test. Each vertical line passes through our graph only one time. However, y equals sine of x is not one-to-one because it fails the horizontal line test. There are many horizontal lines where it crosses our graph more than once. So as a whole, if we consider the entire domain of y equals sine x, we cannot right now, with the entire domain of y equals sine x, we cannot have an inverse. However, we can restrict the domain so that we still span all values of our sine function, but we are one-to-one. So take a moment and think, where could we be where we go all the way from -1 to +1? And there's many options. One option would be from pi/2 to 3 pi/2 because we go from +1 down to -1. So we get all of our y values in there. There's another. It's -pi/2 to pi/2, and that is the one that we're going to use. So by definition, so we are going to define y equals sine inverse of x or y equals arc sine of x. To be the same as sine of y equals x. However, our y values are going to be restricted between our y values are going to be restricted to the interval -pi/2 to pi/2. That way, when you give any input, into the inverse function, you will only get out exactly one output because we are limiting our answers to -pi/2 to pi/2.